So in this video we're just going to introduce Riccatti's equation, and then in subsequent videos we'll develop the solution techniques for it. So Riccatti equation is going to be a differential equation that has the form dy dx equals a function of x plus a function of x times y to the first power plus a function of x times y squared. And what we want to recognize is that here we're using x and y as our variable names. Remember, variable names are arbitrary, so we could just as easily have a function that looked like du dt, for example, equaling p of t plus q of t times u plus r of t times u squared, and this would also be a Riccatti differential equation. So when you're working in the homework, you just want to make sure that you're not letting the variable that's being used throw you off from identifying if you have a differential equation of the correct form. In the homework, and this didn't go very well in the last homework, I think, but in the homework, if you're asked to verify that you have a particular type of differential equation, you need to demonstrate conclusively that the differential equation has the indicated form. So here I start with the differential equation that isn't in the form shown in the definition. I need to demonstrate that it can be put in that form. So we have y prime plus 2xy minus 2 minus y squared equals 0. And in the form I notice that the derivative, the first derivative, is isolated. So I'm going to isolate the y prime, the dy dx term. So I would need to add 2 to both sides. I would need to subtract 2xy from both sides, and then I would need to add y squared to both sides. And when I put it in this form, I'm going to recognize that it is a Riccatti equation. So the equation is a Riccatti equation with, what do we have? P of x is equal to 2. Q of x is going to equal negative 2x. And r of x is going to equal, so I have a y squared here, so I want to recognize that this is the same as 1 times y squared, so r of x is just equal to 1. So again, when you're verifying that you have an equation that has the form, when you're asked to verify, you're being asked to show that it meets the form in the definition. So you have to, if it's not already in the form, you have to put it in the form and then identify the pieces, the relevant pieces of the form.